Did you get it? 4.16.
May June 2021. Paper 42, question 8B. Where this
So let's try quickly this question. Figure 8.3 shows a simple DC electric motor with a split ring commutator. State and explain the direction of rotation of the coil as seen from point X. Let me mark the positive and negative here, and let me mark the direction of current. Current always flow from positive to negative. Current always flow from positive to negative. Magnetic field is always north to south. This is the magnetic field. I have shown the current. This is current and this is field. Apply Fleming's left-hand rule. Apply Fleming's left-hand rule.
did I study this topic?
Yes, you have studied DC motor with me. You have studied loudspeaker with me. Remember that motor effect, split ring commutator, and so many animations there. So Fleming's left hand direction of rotation of the coil is seen from point X. So you people have to put left hand rule first on the left hand side. If I put the left hand rule, you have to see that the current is coming towards us.
The thumb points towards the direction of the force, and the four fingers point towards the direction of the magnetic field.
So one side the force is upward, and one side the force is downward. So look at these two direction of the forces, Fleming's left-hand rule. So how the coil will rotate, clockwise or anti-clockwise? I have mentioned the direction of rotation is asking. So what would be the direction of rotation? The coil will rotate this way. This will be the coil rotate clockwise or anti-clockwise. Clockwise. What is the explanation for this? You will tell examiner that we are using, this is according to Fleming's left-hand rule. The coil rotates through 90 degrees from the position shown. What happens to the movement? What happened to the moment in this position? When the coil becomes vertical, the moment is actually changing, and you people have to remember that when a coil is moving, the moment changes like this. This is the moment graph I had drawn like this one. The moment increases and decreases. Moment increases and decreases. So when the coil is perpendicular 90 degrees from the position shown, the coil will be vertical between the plates. So look at this diagram. I made it here to explain this part. This is north, this is south. So the coil has become, the coil will be vertical between the plates. This is the coil position. Now the coil is vertical. This is the force and this is the force. When the coil is vertical, the moment will become zero, because when something is in its vertical position and the force is acting on it, the moment will be zero. So you will tell the examiner that moment at that point will be zero. When something is vertical above the pivot, the moment will become zero. So understand this concept here again. This is a rod, this is the pivot, and this is the force. Moment is maximum. Acha, make it vertical, and this is the pivot, this is the force. Now in this vertical position, moment will become zero. And in this horizontal position, moment is equal to maximum. The coil is rotated through 180 from the position shown. By considering the forces in the coil, how the split ring commutator enables the motor to turn continuously. This is a memory. What split ring commutator does, it reverses the direction of current. This is the function of a split ring commutator. It reverses the direction of current after, this is a memory. Remember this working of a split ring commutator. Now, this is the concept of a DC motor. In the chapter of electromagnetism, motor is the most important topic. So we'll stop here and we will inshallah do more questions inshallah in the next class. Allah Hafiz.